That was absolutely amazing to put together an experience in virtual reality. And it's clear that the future of entertainment is built with imagination and creativity and, again, enormous amounts of data. And data is the foundation of innovation, and of course it's impossible to talk about data without thinking about the future of computing itself. And this is something we've been tackling at Intel since our earliest days. Tonight at CES, I want to give you a preview of where computing will go next. One of the fascinating developments is the rise of neuromorphic computing. We've been building something that truly mimics the way that the brain observes, learns, and understands. Our research efforts have produced a prototype chip called Loihi. To understand more, let's hear from some of our team that has been working on it.
Traditional computing rests on this basic idea of you have two computing elements, a CPU and a memory. And neuromorphic computing is throwing that out and starting from a completely different point on the architectural spectrum.
Our own brains are remarkable in what they can do. We're simply trying to learn from what our brains, the brains of animals, can do to make systems that are smarter and more efficient.
And what we're looking for is to connect all of the neurons in the chip much like we would with an actual brain. So neuromorphic computing is basically the concept that we're going to simulate the brain in silicon.
Neuromorphic computing will show up where they find an application that benefits from being able to embed the intelligence into a device, initially in areas of robotics, autonomous vehicles, where the power and the size and the adaptability are really beneficial.
There's a number of different ways it can go, and we can see it filling out the whole extent of machine learning as people have envisioned. So it's a generalization of computer architecture to really provide the right tool to implement artificial intelligence.
What Loihi provides is just like your brain, it's going to connect up neurons to get together, and the way your brain learns is it changes the connectivity between your neurons. What Loihi gives you is the capability to build a network, and then you feed in data, and then it will change the network as you're going and learning, and it will tell you what the result is, online, at the edge, in low power.
It's really fun to be a part of a project where we have the strength of a company like Intel to invest in these areas and to really solve these hard problems with the whole portfolio of great technology and talent. And neuromorphic computing is an extremely hard problem, but it's one that Intel's scale and expertise can really be brought to bear and make a real difference in the industry and for the world.
So as you just heard, neuromorphic computing has the potential to change the way devices understand and interpret data. But of course, that doesn't happen automatically, and these devices have to be trained with data in the same way that the brain learns something new for the first time. This has been a major research effort at Intel, and today we have a fully functioning neuromorphic research chip. Our Loihi research chip is the most advanced neuromorphic chip yet developed, and after only a few weeks, it's already performing simple object recognition in the labs. This incredible technology is going to influence future products and innovations. And in the years ahead, Intel will put Loihi in the hands of our research partners to unleash the true potential of our prototype. We're really optimistic about what this new kind of computing can achieve over time. I'd like to take another leap in computing, though, and this time make it a quantum leap. And let's talk about quantum computing for a second. And quantum computing represents an entirely different approach to computing. This technology will be able to solve problems that are insurmountable today. Quantum computers are composed of quantum bits, or you often hear the term qubits. They use massively parallel processing to solve problems that today the best supercomputers will take months or even years to resolve. So what can you do with all this computing power? Well, one possibility is you could model chemical molecular interactions for drug development. And this often requires testing endless combinations of molecules to find the right solutions. And with quantum computing, this process is dramatically accelerated. This is just one example of how we're thinking about quantum computing today. Just as we ushered in the era of our classical personal computing, we're pushing the boundaries of the quantum computing revolution. Our labs and researchers are committed to these innovations, and we see it as fundamental scientific and engineering challenge. Now, we've been working with the leading QTech labs at Delft University in the Netherlands to test and build full quantum computing systems. And you've probably heard us talk about our 7 and 17 qubit systems. Well, today, I'm proud to show you the next step. I'm proud to introduce to you our 49 qubit quantum chip. This 49 qubit chip pushes beyond our ability to simulate and is a step towards quantum supremacy, a point at which quantum computers far and away surpass the world's best supercomputers. We expect to solve key technical challenges that must be overcome to move quantum computing forward. There's quite a bit more work required than just this chip, but this is a major breakthrough in quantum computing. We're going to continue innovating in this space to tackle life-changing complex problems and believe the most impact will be in things like materials science and the discovery of new materials such as superconductors and new molecules to advance pharmaceuticals. The future of both neuromorphic and quantum computing are coming much faster than anyone imagined. And I'm confident that they'll transform our lives for the better. The next generation of computing will be more than about technology. It will also focus on how the industry positively impacts society. This is where Intel has made significant investments and impacts over the years. 4 years ago, on the stage at CES, I talked to you about conflict minerals. And after careful researching about where our minerals were coming from, we committed to use only conflict-free minerals in our microprocessors. Now, through further effort with third parties and direct validations by our supply chain, we've gone well beyond microprocessors to ensure that every product is labeled conflict-free. Three years ago, we took a hard look at the data about women and underrepresented minorities in the technology industry. And we knew change was needed. In 2015, we set a goal to invest $300 million over 5 years to improve diversity in our workplace. And I'm pleased to share with you that we've had great success. We've increased the diversity of Intel's US workforce, and we'll reach our full representation by the end of 2018, a full 2 years earlier than we committed. And that's a major milestone for the industry. We'll continue to publish our data on a regular basis to prioritize diversity and inclusion, allowing Intel employees to be part of a culture that positively impacts society. Now, there's a next area that we believe we can go and impact society, and that's in safety and transportation. It's not an exaggeration to say that the rise of autonomous cars will be the most ambitious data project of our lifetime. It's significant and will reshape our cities, our transportation systems, and beyond that, it'll be one of the most positive social forces technology has ever unleashed, because it's going to save lives. Autonomous driving studies estimate that over 1.25 million lives could be saved as a result of fewer fatal car accidents. Over 157 hours of commute time can be saved per person every year through autonomous vehicles. And over $150 billion in fuel costs can be saved in the US economy over the course of a single year. As you can see, the impacts will be enormous. We want to push this technology even further. We want to build a platform that allows autonomous cars to become a reality, from commercial fleets to passenger cars everywhere on the road. This isn't just an experiment, it's a path to the future. It's not just the technology, it's about the safety as well. So to help us understand why I believe autonomous vehicles are closer to reality than anyone realizes, let me introduce one of the world's great entrepreneurs and an expert in autonomous driving, the co-founder of Mobileye, Professor Amnon Shashua. Welcome to CES, Amnon, a great entry.
Thanks, Brian. It's great to be here.
So I saw no hands on the wheels, but this doesn't look like the traditional autonomous car. There's no big LiDAR on top. It just looks a little bit cleaner and smoother.
Well, first, I'm proud to introduce one of our first vehicles out of a fleet of 100 cars that we announced last year. And indeed, as you said, all the sensors are very discrete, unlike what you normally see in the media.
So last year, we had the pleasure of welcoming Mobileye to the Intel family. We believe Mobileye has developed the most powerful technology for autonomous vehicles, including this car you arrived in.
Mobileye is proud to be part of Intel, and we are excited to be working together on building a world of safer cars.
Yeah, so I think this audience would be interested a little bit in understanding how exactly the Mobileye technology can lead us to a safer future with fewer accidents, and how you really see it playing out.
Well, it starts with sensors. We have cameras, about 12 cameras around the car. We have a cocoon of radars and laser scanners, LiDARs, all fed into high-performance computing system on chips from Mobileye and an Atom architecture by Intel. So when we talk about cameras, we have 3 cameras in front, 3 different fields of view, which gives you about 180 degrees in total, and very high resolution. So you can see about 250, 300 meters range. We have cameras, wing cameras and side cameras that give you half a sphere on the side, a rear camera, and then 4 parking cameras, altogether 12 cameras, and then radars and LiDARs for redundancy. And I think we'll say bye-bye to Yaman. Thank you. So the social cost of road accidents is just too great, and we believe building trust between our consumers and the vehicles is critical. So we have identified 4 areas that we are addressing to make autonomous vehicle real. First is sensing, and that includes all the high-performance computing. Then mapping, driving policy, which is about planning decisions and merging into traffic, and then models that provide safety guarantees, which are coordinated with government regulations.
Okay, so let's start with sensing, since that's like really the root of these cars. I have this great visual of a car behind us. Can you help us understand what role Mobileye plays in the sensors?
Well, let's start with today. Today, Mobileye system on chip and software powers driving assist cameras on over 24 million cars. So 9 million of them installed during 2017. Now, we had 30 design wins with 27 car makers during 2017, and we'll be launching 15 production programs in 2018. So most likely, if you're driving a vehicle equipped, if you're driving a vehicle, it's equipped with Mobileye, and this is real reality. And our technology enables driving assist functions such as automatic emergency braking, lane keeping support, traffic sign recognition, and much more. And we are in many different car brands on the road. This includes Ford, GM, Audi, BMW, Honda, Nissan, Hyundai, and many more. Okay, so can we talk about how this all works? And so I've got the sensors now. How does it really come together? Well, there are 3 pieces. So in the car that you have just seen, you have an architecture of computing that processes the raw sensor signals and creates an environmental model with every detail around the car. So we're talking about road users, objects, and drivable paths. Then we have massively advanced driving policy software, and using reinforcement learning that makes decisions of driving maneuvers that are, and including assertive ones, and providing safety guarantees together. Into this mix comes also high-definition maps, which creates further redundancy and foresight of drivable paths to make sure that nothing of value is missed by the system.
So I think you and I are big advocates of this technology. How fast do you think this is advancing? What's the rate of advancement here?
Well, actually, very rapidly. We are developing faster processing chips and superior software, and the very best architecture combining Mobileye's IQ system on chips and Intel's Atom architecture. To be more specific, in few months, we are sampling our 5th generation system on chip, the IQ5, that is expected to run 24 tera operations per second at an extremely low power of 10 watts. Raw computing density is important. That's the 24 teraops. Diversity of cores is also important in order to run different workloads, but power is crucial.
Right.
You know, this machine needs to fit in a car, most likely powered by a battery. So every watt counts.
So that 24 teraops at 10 watts is an important set of parameters.
It's not only important, it's the best on the planet. And, you know, the industry knows that we're pushing the boundaries. In addition to our level 4 partners, BMW, Fiat Chrysler, Aptiv, NIO, our latest addition to build together a level 4 fully autonomous car is SAIC Motor, the largest automaker in China.
So you've told us about the sensing, but you know, one of the real breakthroughs that you and I have talked about is in the mapping. And after all, mapping is that data that's so important. So can you tell us how you see that all coming together with Mobileye?
Well, first, when we say mapping, we're not talking about the conventional navigation maps that we are all familiar with. We're talking about maps that are required for supporting autonomous driving, and they require levels of details you cannot find in navigation maps. And creating these high-definition maps is a big logistical problem. Even more difficult is keeping these maps updated in real time. And we believe that crowdsourcing is the only solution. And this is possible because Mobileye has both the crowd. We have tens of millions of cameras on cars. And we have a technical solution capable of compressing the data small enough to communicate over wireless networks. We're talking about 10 kilobytes per kilometer, which is really nothing. So cars equipped with Mobileye cameras and chip act as data collectors, as harvesters, and continuously update the high-definition maps. And we call this data collection road experience management, or REM. Let's take a look at how it works in the following clip. So what you see here on the left display, you see mapped data, these colored lines projected onto the image frame. And these lines are sitting exactly on real lane marks on the road. So this gives you a sense of accuracy. We're talking about accuracies at the level of centimeters. On the right display, you see the same information but projected on Google Earth, again, to give you a sense of accuracy. And accuracy comes from the accuracy of the map data itself, but also accuracy of localization. The system in real time localizes the car inside the map. So crowdsourcing is the most affordable way to create real-time, up-to-date, and accurate maps. And the industry is on board. We have production programs this year, launching from BMW, Nissan, and Volkswagen. They'll be equipped with REM and begin crowdsourcing and updating the REM map in 2018. We have global mapping is advancing rapidly, and one of the most exciting areas of autonomous driving. We are announcing today 2 new mapping partnerships in China with SAIC and also Navinfo. And with these new relationships, REM is in every major market.
So, you know, you and I have been big advocates and believe in this technology. And the critical piece will be getting the regulators and the local governments to really help us make this a reality as well, correct?
Well, I agree, Brian. We are embarking on the most ambitious and comprehensive plan to formalize the common sense of human judgment of driving, and create a model of safety we call RSS, that together with regulatory bodies will make autonomous vehicles a reality. And this week, we'll host conversations on precisely this topic. There's a lot of interest, and I hope you join us.
Okay, so Where do we go from here?
Well, I think it is time for you to take a tour in our technology and take it out on the roads. And the car that you have just seen is yours, and you'll start driving with it from home to work.
Thanks a lot.
Thank you.